Welcome to the Sixth Stages Mini Partner Workshop. Today, we are joined by Evan Turner from the Texas Water Development Board. Before we get started, I would like to go around the room and everybody introduce themselves. Okay, please stand and share your name, your research interests, your program, and how far into your program you are. The camera is right there. Andy.
Hello, I'm Andy. I'm a master's student in chemistry, and right now I'm studying seagrass genetics as it relates to alkalinity and groundwater.
Hello, my name is Justin. I am a first-year PhD student in the Coastal and Marine System Sciences program. My research interests align with studying organic matter cycling and analytical chemistry.
Hi, my name is Allison Gerard. I'm a first-year PhD student in the Coastal and Marine System Sciences program here. And my research interests have to do with nitrogen, biogeochemical cycling, and analytical chemistry method development.
Hi, my name is Quincy, and I'm a first-year master's student in the CMSS program, and I use satellite radar to study extreme precipitation.
Hi, my name is Laura. I'm a first-year master's student in the Coastal Marine System Science program, and my research focuses on groundwater pollution with a combination of social science.
Hi, my name is Ifai. I'm a first-year PhD student in CMSS. My research is centered on groundwater pollution and also PFAS in groundwater.
Hello, my name is Remy. Hello, I'm Remy. I'm a master's student in the chemistry program. It's my first year. My research focuses on epigenetics and toxicology.
Hi, my name is Bee. I am a fourth-year PhD student in the BARB program, and I was part of the Stages cohort last year, and I'm the peer mentor this year, and my research has to do with developmental immunotoxicity, specifically with PFAS exposures.
Hi, Evan. You may remember me from somewhere before, but anyway, I'm Blair Sturp, a boat rider. I'm retired, but hanging around to do statistics occasionally, so.
Lucy.
Hey everyone, I'm Lucy Flores with the Texas General Land Office, and I'm the Texas Beach Watch Project Manager.
Patrick.
Patrick Nye, Ingletown of the Bay Coastal Watch.
Josh, I know you just joined us, but if you could give your a short introduction.
Sorry about that. Hi, everyone. My name is Josh Oyer. I'm with the Texas General Land Office. I work on the Texas Coastal Resiliency Master Plan, and just kind of here to listen in and see what the Water Development Board has for guidance for the group. Thanks.
And I'm Audrey Douglas, the program coordinator for the Stages NRT. And my research interests are in groundwater surface water interactions in the coastal zone and their impacts on nutrient cycling. I am an alumni of the CMSS program. Dr. Vasilieva, would you like to introduce yourself very quickly?
Oh, sorry. Hello, I'm Maria Vasilieva, Assistant Professor of Applied Mathematics from the Department of Math and Statistics.
Okay, so without further ado, I hand it over to Evan.
All right, thank y'all so much. So I'm Evan Turner, alumni as well of A&M Corpus Christi twice over, which I'll tell you about. And so my goals for today is really to give you some ideas. I'm going to share a project that I worked on as a doctoral student there under Paul Montagna, and what data offerings that the board does, what we do, and some data offerings that are not from the board as well, to kind of get you thinking And so my goal is to try to get you into thinking about freshwater inflow as a problem when you're developing work. So at the moment right now, I have a lot of project ideas for people to work on. The problem is that we're in the middle of just hiring and hiring and hiring. And I'm starting a new role as well in the board. And so we really don't have time to um, really mentor students very closely for a particular project. So that's my goal today, is to just give you a roundabout idea of what we do, what data products you could use, and some ideas. And so it's always exciting to be part of this program. The last cohort was really fun. It was really neat to see how you went through problems, um, how you decided what data to use and what to work on. And it's neat to be part of that and sort of steering people. So always to know that I'm a resource if you're looking for particular data, or you have an idea of how hard would this be to get this data or manipulate it or do a project. So I'm always there as that resource, and so is everyone at the board as well. So I'm going to turn the camera off because actually this screen is over here, but I need to look at my things over here, and then that way it won't be as distracting. So okay, so the first thing is I do have to say, unless specifically noted, I don't have official board positions on this presentation unless otherwise noted. It's kind of a boilerplate thing, but I've had it actually come up a few times. I think it was actually in this group I had a few really tough questions before, and it's something when you get a government job and you realize that, well, the board is a political appointee and you're an employee at a government institution. Um, Things just don't necessarily always align, and you don't want to say something that's a policy, right? So again, it's an important role, is like when you start moving into working into getting a job, and a lot of our past cohorts already moving on to jobs, and a lot of them are in government. It's just part and parcel of what you deal with now. Okay, so who is me? That's actually a pretty old picture, but so I got my bachelor's from A&M Corpus, and it was at least in this century, so I'm starting to date myself pretty good now. And so I was originally a computer science person. I worked at the UT Advanced Computing Center. I did supercomputing there, and when we built clusters, and I did a lot of the programming. And in fact, one of the main things I did was porting code from 32-bit to 64-bit. That was the big thing that was going on at the time. And so we were having to port all of the computer code to 64-bit. So it was very, very much into just hard skills. Then I decided, well, I want to get an MBA. I want to really round my skills out. So I got an MBA. Then I taught middle school in Corpus for a year, which was quite fun, Texas history and science. And then I went back to A&M Corpus, and I worked under both Sadovsky and Paul Montagna in the CMSS program. So I'm a CMSS student grad in 2016. And since then, I have been employed at the Texas Water Development Board, which has been quite fun. And I've now had maybe 3 or 4 completely different positions at the board in that time frame. So it's been 7 years now that I've been at the board, and that's long enough to essentially be really senior staff at this point. And so what do we do? And my elevator pitch for the board, the elevator pitch is, what do you do? And somebody gets on an elevator and say, what do you do? The board is really a bank. That's our main process as a bank. So when municipalities want to get a loan to improve their water, so like you go vote and they say, vote on this bond to give us more water for fix our storm drains or otherwise our reservoirs, they actually get the loan from the board, and that's one of its main functions. Past that, the board is essential in planning for the state for water resources. And then there's a science side. And so I work in the science side, water science and conservation. One of the big groups I worked in was the coastal group, the basin. It used to be basin estuaries, now it's coastal science. And then now I've moved up in the last few months, and now I'm at the divisional level, the surface water division, that maintains essentially all the surface water in the state. And we'll get to some of those items. So one is coastal science, and coastal science provides data, models, and analysis really for environmental freshwater inflow, which is my main science that I deal with in CMSS. And there's a bunch of different activities in there and different data sets that you can play with and look at that we do, which I'll get to at the end. A lot of it is, bathymetry, flow modeling. Salinity is kind of our main value. We will take other data like dissolved oxygen, pH, chlorophyll, but conductivity and being able to find all the conductivity data is really the bread and butter. Next is river science, which now as you move into the river, and most of it is flow. So river flow and sediment transport. That group works really closely with USGS, and we have contracts that will pay for a lot of the stream gauges from the USGS stream gauge flow. So we do rehost some of that data. Typically, we just point people to USGS, but we actually fund a lot of that data and a lot of that science, and that's where it comes from. So if you're interested in doing sedimentary flow or otherwise those models, that's the group to talk to. Next is there's a group called water availability. It's a little complicated. So in the state, if you have water, you have a thing called a water right. The water rights are maintained and managed by TCEQ. However, the water board runs those same models in order to give data for planning purposes and inform regional water planning and to make sure that, hey, we are matching those flow standards. And so they put out several reports. Also, the things that they do is taking data for evaporation in the lakes, which is a kind of a new exciting thing. And so one of the pictures here is we have these buoy systems. It's the same buoy that we have on the coast and in the reservoirs that actually have meteorological stations on top of them and water quality. And they come up with metrics for, well, how much water is actually evaporating out of the reservoirs. They also deal with the drought predictions as well. So there's a drought forecast that comes out. And so it's actually quite interesting right now. We have floods that are going on in essentially east of I-35 and the west of I-35, which is where y'all are in drought. And so this is why these groups are really important to have. The next is a group called Hydrographic Survey. They're actually, we call it a cost recovery, which is they actually charge money. It's like a little business. The reservoir operators will contact this group and they will make very high detailed surveys with instrumentation. This is instrumentation surveys of the sediment impoundment in reservoirs. And this is to say, what is the true capacity of that reservoir? And so there's a lot of really neat science to go along with that, with mapping that they do in extremely large data sets in terms of mapping those reservoirs. The next is in flood science is TexMesonet. Flood science shouldn't actually be, that got moved out, but TexMesonet is a group, they're under surface water and they install and maintain weather stations all through the state. And right now they have 106 weather stations, but their data viewer also has partner stations, like 1,500 partner stations. And the data backlog from that. So at the end of the presentation, we can go through that as well. So if you're interested in, say, hitting the API to get historical data from all those weather stations, you can do that. So it's a lot of data. It's the largest amount of data collection we have at the board, and all that data gets filtered into the National Weather Service for our national forecast. So that's my spiel about the board. What I want to get into is my little foray into environmental science. But here, one thing I did want to share, a little example. I worked in the coastal group on the conductivity measurement in the coast, and so this little graphic shows all of the stations that we had during Hurricane Harvey, and the yellow line there is the track of Harvey. So if you remember, Harvey went into the coast, did a little loop-de-loop, came back out, dumped a bunch of rain, and went back in, right? And so to give you kind of an idea of the data that we collect and present out, this from all those stations, this is the salinity measurements that were occurring in the bay systems at the time. And this turned into a paper, probably several of, and we don't really know of all the people that really use the data, but one from A&M College Station used this, and so you can see the just complete drop off of salinity. But what's real interesting is how long it took the bays to recover, and so that's part of the science that we can help with is, well, how long would salinity come to recover, which again has a lot of implications for the oysters at the time. And so Galveston itself had a real hard time after that, keeping stock alive. Another one was really interesting that I thought was very, very neat. This is a long-term trends of water temperature from those sensors. And so on the left of the screen, you could see this day-night cycle of water temperature kind of going up and down, up and down. Then through Harvey, that the temperature drops pretty significantly and then stays low. And it took a really long time for that to recover. So, I mean, it's not necessarily a scientific talk to say, the hurricane like sucks the heat out, but it does. As the hurricane builds, it uses the heat from the water, and you can really tell that even after the storm was fully gone, after multiple days or week passed, the water temperatures still did not recover after the storm. So it's really interesting to see this. So this is one of the neat things of working here. You put these instruments in yourself, calibrate them, decide, hey, where I was going to put this, and then something happens like this, and you actually get to see the results. So it's something that's really neat about this kind of job. So what I want to really talk to you today about is inflow science. And the Water Board has been one of the key partners in forwarding freshwater inflow science, really in the nation and in the country. One of the big things, we called it the Freshwater Inflow Bible, is this book that came out by Longley in 1994. And Paul Montagna's actually revisited this recently to make a next version. And some of the main questions is, how does salinity really affect estuary health? And these basic questions like, do you know how salinity changes will affect individual species and individual health? But then past that, well, what does the role of freshwater inflow play to alter salinity? So each of these questions are separated that different groups have had to work and work on, really for 50, 60 years. And it's really interesting when you read some of these really old texts, they thought this was done like in the 60s. They were like, oh, this is a no-brainer. We could solve this. This is easily done. And they come to realize that it's not so easy. It's not so easy as they thought. to derive these answers. That, you know, we don't have a one-to-one, water goes in here, salinity changes here, you need a model for that. Then you don't have a one-to-one of this particular species wants this particular salinity or this condition. And so there's still a lot of room for science. And so an example of, like, this is kind of a gold standard. This is not mine. This is just on Science Direct of the what you would want to see. You want to see the physical factor off the x-axis and the biology on the y-axis. How does the physical process change the biology? And then you get these sort of qualitative features of it's tolerable, it's optimum, and then intolerable again. And this is like the coup de grace, the gold standard of what you want. And to realize that years and years and years amount of work and testing go into trying to figure this out. So, you know, fast forward now, I am a postdoc. I just graduated CMSS. I was in Paul Montagne's lab, and he said, "Okay, I have some funding for you because I need to find a job." He had some funding for me, and he said, "Okay, I want you to work on this program. This is what's going to pay your salary. We have a field program to monitor Matagorda Bay salinity flow and do benthic fauna." So that's what Paul's group did at the time. You know, do this work. And essentially, answer this question. What we want is we want a graph just like that. Show me salinity one side and the population another to say how healthy it is. No brainer, right? No big deal. So this is not me doing, but this is what they did. They had a series of stations that they set up to study benthic samples. They pull cores, do counts. That's what his lab did downstairs. And HRI, I don't know if that lab is still there. I know that they're sort of wrapping up, but that's what that group, you know, worked on at the time. So the postdoc dilemma, and this is probably what happens to every postdoc. So I joined the study at the end of the project. I didn't have any involvement in how they developed it. They did not have a lot of the benthic samples processed yet because that does take a really, really long time. The problem was the samples they did have processed really didn't show a lot of relation to freshwater inflow at that period, and mostly because they didn't have a lot. Okay. The problem was the grant funder wanted results in 6 weeks, and Paul just kind of told me, "Well, you're the postdoc, go figure it out." I think, you know, like the literal quote of "just go figure it out." So I was, you know, this, like, I'm a newly freshly graduated. I'm trying to impress, but I basically I decided that I don't think we can really look at the benthic fauna that they had samples for, even though they got paid to do it. It didn't show enough, and it would not get done in 6 weeks. Or when not just 6 weeks, I needed to get analysis basically now. I needed to get data to data study, not wait 4 or 5 weeks for data to do. So the first thing was, okay, I'm going to have to find a new species. The second one is well, nobody's really looked at the freshwater inflow side yet. You know, that other the y-axis and the graph. So I have to look at some sort of model for altering inflows. It's not like we're going to get a big water hose and put water in the bay. You know, I'm going to have to use a model to test this. So our group hadn't done anything with that either. But we had a subcontractor that was scheduled to at least do a little work in a model called TextBlend. So I think that I was like, okay, I think I'm going to have to go through that. So the first thing is, okay, I'm going to switch and I'm going to do oysters because, of course, I'm not a biologist. This is the first time I've ever done that, but these are the reasons I chose it. First thing is they don't move. They're sessile. They stay in one spot. So anything that happens is going to happen over top of them. I knew that was going to be important in the study. They're heavily influenced by salinity levels, and there's already whole fields of science that is devoted to that and done in research. That's a done deal. Okay, so that we're not reinventing the wheel. 3 is the reasonably large populations, at least in the study area. The major one is the Parks and Wildlife Department has a humongous data set, which I already sort of worked with this set before in the area of catches. I don't know if y'all have heard of that data set, the Parks data set, but it's a great wealth of data that has not just oysters in it, but other kind of grab samples. But it's a lot of data, so I know I could go through that. And the other one is it's an economic crop. So if someone was going to try this to tie this to money at the end of the day or otherwise importance, I mean, it's important. So people are going to want to take note of it. So just looking from the literature, these are just some basics ideas of the oysters. Again, other than eating oysters, I had no knowledge of oysters when I started the project or what it was, but I at least got a roundabout of, okay, here's sizes, what their ideal salinities are. Now, what's interesting about them is that there's 2 different groups. There's called the spat. Those are the babies that they have a certain spawning month, and they actually have a higher ideal salinity than the adults do. The other big thing is they have these diseases called dermo that destroys their tissues, and it kind of thrive in higher salinity, higher temperature, which is in the summer. And then there's other mortality, like if they get below 2 parts per thousand for a particular period of time or very high, then they die as well. So with that, I came up with some very, very simple set of equations that mirrored a lot of these others, called an HSI, mirrored a lot of these other ones. And if this is data that, again, that I could find, that I could really come up with from the Parks data set and the salinity models that we had. Okay, so now I've got my model, and I'm reasonably confident in that. And then I asked a few oyster experts, say, hey, is this a really simple model? I know the reef locations in the bay. Would this work? And they said, yeah, that looks good. It's simple, but it should work. And then again, for each of these, I know I can get data for it. Back. So this is now the model that we used. It was a waterboard model. Of course, this is before I worked at the waterboard. There's a model called TextBlend that the coastal group maintains, and they have it's a daily estimate of salinity from the 80s all the way to modern day. And what was instrumental about this is that I could pick a node in the model, like one point of the grid, and that point of the grid was on top of a reef. So within that, I get a reasonable idea of what the salinity is, and it follows the trends. It's not, the fit isn't great, so the fit is 0.75 R squared, which for a physical model where you say that's terrible, for salinity model is actually not that bad comparatively. So you could see the model versus the observations, but at least in the long term, you're looking at 40 years, it at least somewhat matches. It looks good. So again, that gives me that x-axis of the graph that I'm trying to do. So the order of what I was going to do things is, first I need to calibrate that HSI, the oyster HSA model, to the Parks data set somehow. I have yet to figure that out. I mapped the reef to the TextBlend node. Okay, that's easy. Could do that with the images that we have. I run TextBlend then with altered inflow scenarios. So this is the concept. I'm going to add water to the gauged inflows, and then I'm going to calculate how that changes salinity on top of those reef items, all those reef locations. Then I'm going to run the HSI again. And then at that point, then I can find what is the optimized inflow to growing oysters at that locations. So that's the concept I came up with to work on. So it turned out that fitting these equations to the parks data set was a little bit harder than I realized. I realized there actually wasn't a mathematical statistical process to do it. So this actually turned into a paper, this process that we came up with. And so the example is on the right. And I'll show you another great graph that shows this. So if you ever do any of these kind of ecological samples in the bay, there's a whole lot of stuff at the zero line, because either you don't see it, that doesn't mean it's not there, you just didn't see it when you went sampling, or otherwise it's just a big scatter plot. But what you want to find out is what is the ideal optimal growing condition of that organism. So to put your, calibrate that line. So that's when we came up with this concept of this max bend regression method, to try to fit that line. So here's an example of what that oyster data looks like from parks, and I say it's a mess. That is the oyster spat number of individuals that parks found in Tres Palacios. And that's the same as that when I ran a normal regression line over that, it didn't really work out that great. So what I wanted to find out is what's the maximum number of individuals, the top of the top of the peak, and also what's the ideal salinity, right? So again, so when you look at that scatter plot, you can kind of visually see there is a trend there, but then how does that turn out? And so through that process, then we were able to calibrate these simple models, these little simple lines. Past that, now we're matching the reef distributions, which was from this oyster survey. I think that oyster survey was somewhat part of that grant, or at least it was data that we were able to get. But that way I can find where those reefs are in addition to the sample areas that we did sample on and we were paid to do. But then to also then match that up with the mortality and dermo and growth. So the results. So after I ran all the models and ran them many times and did an optimization, I found that for each of those stations, if we were going to add enough water to the bay to lower salinities to, where it would be, it's going to take a lot of water. I don't know if you can see my cursor, but you get a pretty good drop at first, but then past 5,000 acre feet, you get diminishing returns. So then now I turn that in to running the HSI. But what I did find, and this is that first part where I said, there's two different oysters I had to worry about. One was the juveniles and one was the adults. I found out that the juveniles is where we can really win here. Since the juveniles optimal salinity was much higher than adults. So we realized is there is actually an optimal point of water to add that is actually sustainable to lower the salinity at those locations, those reef locations for spat in the summer. And that was actually something that's actually attainable to do. So, and that made this whole thing was a winning project. So that was the crux of this. And so the funders were super, super, super happy. They were amazingly happy that we did this. And this has actually turned into one of the key concepts in the state now about protected flows and this concept of buying water rights and releasing water in the bay at specific points. And so there's a group called the Texas Water Trade that got started after after this, that one of our board employees now, Kevin DeSantiago, works there. And this is one of these kind of key concepts is, could you possibly buy water, a water right, and actually have some utility for that water right to make some sort of environmental gain, which is really neat. So yeah, so that is freshwater inflow science, kind of its heart. It's an interdisciplinary field that you combine biology, ecology, physical hydrology, a lot of computational modeling, and a lot of very inventive statistics. and sometimes all of those items at once. And so anyway, so that's my little foray into that. I want to kind of give you some ideas. Before I go on to like look at data and data products, do any questions about that study from y'all?
No.
Okay. All right, good to go. So I want to show you now, take a little time. I know this is like a 2-hour thing. I really didn't want to have to take 2 full hours. It's up to y'all. But I wanted to show y'all the data products that we offer and some data products that other people offer as well, and kind of where to find stuff. So the first is, there's this group called the it used to be called Tenorus, now they're TextGIO. And let me grab that. So and their data hub. So the TextGIO group, they're part of the board, but they're almost their own agency. They're sort of like they have their own name. In a way, they're just kind of too small to be their own agency, so they live with us. But their job is to essentially catalog and curate all of the imagery in the state. It's a lot. And that could be bathymetry, otherwise anything in the state. If you are in any way interested to find a map in the state, or imagery, or LiDAR, bathymetry, that is the group to ask and to go through. And so just some examples. So this is their data viewer. I believe most of their catalogs are online. However, there is a lot that you can get through them. And I would recommend I know a few of them that if you're interested in talking to some people, let me know, because to be honest, I'm not like 100% loving the website myself. So if you were looking for shape files of the state, shape files for anything, they're the people to have. I'm not a, this is like a new data hub. I'm not a super fan of it, to be honest, but at least it works. Land parcels, watershed boundaries. And I think their catalog is in the tens of thousands for their data products. Okay, so that's one. Anything to do with shape files. The next one is the Text Mesonet group. And that's the group that has the weather stations. So, and when this pops up, this is their website. And they show, in addition to their own stations, stations by the West Mesonet. So it's about 1,500 more stations involved in that. And this isn't, again, it's not the absolute best for poking around in. However, what's really neat and neat probably for y'all to look at is there's a backend API. So if you're interested in finding precipitation, temperature, or any of the mesonet fields, and also by time, then you can go backwards in time and collect all of their data for any of the stations that they have. So that's what I wanted to really show you about the mesonet. So one, let's see, and it'll say TWDB. Like this is one of their stations. So one of their stations, you could go back and collect all that. There we go. So data products, so these stations, then custom downloads, let's say. Okay. Let's go back. Dentler. Okay. Daily. Earliest available. Is it, so through the interface, you can get, this is the earliest available here. If you contact the group, you could probably get more if that station existed for that point. Again, they've put 100 and so stations in the last 5 years, so that it might not even exist before that point. So let's say 2022. 1 year. Oh. Let's go back. Cover 6. Okay. Okay. So if you're therefore interested in some project you're doing and you wanted to get rainfall data from the actual stations in those areas, this would be the place to do it. You can get that. Okay. So the next one, there's the groundwater viewer. So I think which there was somebody that was doing groundwater, surface water, groundwater interaction in the group, right? I seem to remember. This viewer, and this is about as clouded of a point as you could possibly get. This groundwater viewer has every single well in the entire state as a point. And so if you have a project that has anything to do with groundwater or aquifers, this would be the site to go to look at. Or if you're otherwise interested in particular well, a particular well site. Let's see, let me turn that off. Go back down here. It's actually quite a bit. Turn the layers off. So unused, 40 feet, historical, and has documents in it. So Patrick, you might actually kind of like this site too, if you want to take a look at your wells in your area. All right.
Yeah, thank you. I appreciate that.
Okay. The next one, and this is actually about half of my job now is maintaining the code for this system, water data for Texas. So I spend about half of my time doing code for this. And so in Water Data for Texas, waterdatafortexas.org, this is the main state's database for looking at our reservoirs, which is kind of one of the big areas people look at with this site. This is actually data that comes from USGS and the well operators. And so, like I said today, it's really interesting. Like on the news this morning, they were talking on the national news about the floods in Houston. It just seems how it always works is that it rains east of I-35, right, and then the west of I-35 is in drought, and then of course Choke and Lake Corpus Christi are extremely low, which has me kind of worried for y'all right now. And so there's reservoir data, which is kind of one of the biggies that people look at this for. Then there's drought. This is the group that does the drought group I was talking about in surface water. And so they have a lot of rainfall forecasts and evaporation forecasts through the state. And so this is more like, I don't know if you would be really using this in terms of your science. This is more of like products for people to look at. But there is forecasts. And so there is that, and then the evaporation forecast as well, and drought index, which is very interesting. And this is where they're working on those buoy systems to try to inform this map. The next is groundwater. So there was that groundwater viewer, but the groundwater on Water Data for Texas is actually, this is actually wells that are reporting data. I don't believe there's any in the area. So the groundwater group will actually go, there's a whole group of people that will drive all across the state to check them, to check their level and put that data in the database and check that the forecast is matching what it is. So inside there, so if you're doing a groundwater type project where you want to actually know what the real groundwater data is, this is the one place in the state that you would get that from, is the groundwater well levels. Okay. We'll do lake evaporation and rainfall real quick. One more. So this is again for the drought group. This is actually the lake evaporation data set that they put out. Again, by it's very interesting how they do it, because it's by these cells, but yet they still have areas in the cells, and then what the gross evaporation is for that area. So again, even if you were looking in the bays, like if you wanted to do something in the bays or near that, this would still be valid as well. So what is the pressure of evaporation in that area? So if you're so interested in using that data for what you have, plus then they have precipitation data like rehosted as well. So if you want to get the precipitation data from that, and I didn't talk about it, but there's this thing called a lake pan. Have you ever heard of that? Anybody ever heard of a lake pan? Y'all understand what this is? I didn't hear about this ever. So there's literally a thing called the pan. It's a metal. It looks like a little trough, like you would have like a water dish for like cattle. And the reservoir operators keep this pan by the main office, and they actually measure that for evaporation. So that is actually how lakes were measured. Their evaporation has been measured for many, many, many years. And so the current research is trying to go beyond measuring evaporation by what evaporates in this little pan sitting on the ground. So then coastal. So first is the water quality salinity data that we have here. I also do at least rehost the locations of other stations that might have water quality and or other things of interest, like these are the tabs buoys that are sitting out there that GLO does. Another one is this is the rehosted Parks and Wildlife data, but it doesn't have the oyster stuff. This is just for their statistics for salinity and dissolved oxygen across the state. So if you wanted to see in a particular area or the state dissolved oxygen, it's kind of interesting. There's another one. This is actually broken at the moment. The freshwater inflow estimates. This is actually what I've been working on in the last couple of weeks, is fixing this. So I'm actually coding the page to fix it. This is off of my computer at the house. But as the data that you could get, I'll show you the data that's offered that you could ask us and we could give you, is if you want freshwater inflow estimates and what is, so there's the water gauge, the USGS gauge, but there's also the diversion and return numbers. That's water that people have been that have a water right to pull out versus water that they give back, and then the actual model amount. In addition, we have a rainfall runoff model as well. So if you're interested in any of that inflow data, that's the group to get it from. And then lastly is the gridded products. That's the TechSplid model in its nodes and what its grids can do. So if you were interested in, say, I want to model a specific area, then which model grid would be appropriate that you want to do. And let's see, does any more on the board? I think that was all the boards. Yep, that's all the boards data. Other data that I thought would be really neat for y'all to see that doesn't belong to the board, but you definitely, I use these all the time, is NOAA Tidens Currents is one. So the NOAA Titan Currents page, that's there. It's all the coastal stations in the state that do water level and or velocity. Otherwise very interesting to look at. So like if you want to pull one of these up, let's pull Packer channel, what its water level is, and other data that it has. So I would think, as well as Patrick would probably knows of all these stations and looks at them all the time. So if you've ever been out like at Packery and you've seen the station sitting by the boat launch, that's one of these stations. Okay. Another one is, of course, the USGS stream flow. I would recommend getting the data from there instead of getting the rehosted board data. I mean, I'm not going to go into too much detail about USGS stream flow, but that's the bread and butter site. It's just if you want data of water flow that's below a gauge, that's really where the board's data comes in. I'm going to say an example here. Not all the time are the gauges at the very bottom, and it's the last either input or output of that stream or river before it enters the bay. That's where you would have to have board data to look into. So and there is quite a bit of more product that they do. It's not just the water level. USGS now has pretty good estimates and models about sediment transport. And so the person that you would want to talk to USGS is named Mike Lee. He works on that project. And so if your project has anything to do with sediment transport, I would highly recommend looking into that. And two more. One other one is called GCUS. If anybody's ever seen the GCUS page, So this is kind of the whole Gulf system of all the platforms, all the things. So this is including the NOAA Titan currents, but then includes this is including the TABS buoys. So these are the TABS buoys, and then the links to them. So this is the GeoLo's TABS buoy, and then you can, in order to download all that data, if you want to get the data from that. It's not super intuitive. At least the way that the site works, but it's able to get. Last one, if you are also still looking for velocity measurements and models, this is called the NOAA goods page. This is the page that oil spill responders use in order to find winds, base map, currents, and ocean models for spills in the Gulf. And so if you were ever interested in getting the NOAA's models, this is where you would be able to get that from. Okay. So, so those are the pages that I use all the time to get data for my analysis. Those between the boards and those. So it's an hour, but that's really all I have for you. In terms of stuff. So any questions, and what do y'all think? I can't hear.
Patrick?
There you go. I can hear you.
Hey, Evan, great job, man. I just like to eat oysters too. I didn't know there's that much to them. Thank you for sharing. Uh, when I was born and raised in Corpus Christi a few decades, well, a lot of decades back, in Oasis Bay was a huge oyster um, uh, habitat, right? In fact, the only way to get from Portland to Corpus back before any bridges were made was across an oyster reef from basically Indian Point to North Beach.
Mm-hmm.
As a kid, we used to see piles of oysters. They'd mined them and they'd set them on the side of the road for roadbed. Have as the have the agencies given up on oyster production in Oasis Bay? Because I know that we can't release a lot of water from uh, Lake Mathis and Lake Corpus Christi rather. But so what is happening to those? I know as you go north, you get a better rainfall, you get better lower salinities. How have you really looked at Nueces Bay and how that's being affected?
Well, the first I would say Jenny Pollock in Pollock's lab are the oyster experts on campus. And so I would definitely direct any and all oyster questions to Jenny. The I do have to say anecdotally, I was at Water Street a few months ago, and they had a choice of they had Rockport oysters in opposed to just Gulf oysters. So I was like, oh, I want to try this Rockport oysters, and my wife really liked them. They were very salty. They tasted very salty. I could not eat it because it reminded me too much of field work. It was way too field work for me. I had to take. I was like, okay, it's not right. So they're around, and they're around in certain areas, and it's more than just the salinity. And so one of the big things that I ignored in my model is substrate. So because I already knew where reef locations were, and we were testing on top of things that were there, is for the oysters to be there, so that the conditions can be perfect and ideal, they have to have the right substrate to stick to for those spat to adhere to. And that is one issue in Nueces and Corpus Christi Bay that, I mean, and as well as everyone here, that what has occurred on the bottom is it's different than it was. With there's the seagrasses, and if it's just dirt, it's much harder for the oysters to attach to. So there's that factor. It's not just fresh water. And so, again, I think some of that question of, what is the state doing for this? That would be, I think, also looked at for, I think that parks would be the one to look at. And I say, like, in that same data set, every single bay had that same equal set of stratified design that parks did to look at oysters in each bay. So if I had that data set super handy that I could pick up and do a graph, I could show you the same graph of samples of Nueces Bay. So I know that they're there. They're just not in the same numbers as they were, at least when even in that where that study began. So, and I don't think it's this is, again, me personally talking. I wouldn't call it the end of oysters all over the place. I think, we're looking into the fishing pressure. I don't think even if the oysters in Nueces, this is just me talking, not the board, just me talking. I don't think that the oysters in Nueces would be able to sustain harvesting pressure. Like, there's just not enough. Even if we had no people living here whatsoever and all the water we had can just go out in the bay, it's so salty down here. I think that they would exist, and if you went in, like if you were a conquistador and you came to this area, there'd be oysters everywhere. But I think the minute you started harvesting them, they would just be decimated. I don't think that they could sustain regular harvesting in terms of the amount of fresh water that we could theoretically provide. That's my feeling. That's my opinion. So I know that they're still there. And again, it sort of even surprised me, even like Karankawa and Tres, but this is Tres Palacios and Karankawa. It's not exactly areas that you thought you're going to go oyster sampling, but there are oysters there, and they do exist. Yeah.
Well, I've been back there fishing a few times, and you got to avoid those reefs. There's still some there that at least are,
Yeah.
and also it helps the water quality as they filter through, of course.
It
I guess
does.
yeah, I guess the billion-dollar question is putting desalination and putting the brine back into the bay. Um, I guess Nueces Bay is really the most protected for oysters, but there's other species of concern. I think there's been some studies on the redfish and maybe the black drum. But so when you're looking at um, water quality, I guess, and that's what
Mhm.
y'all do, how have y'all looked at the bay as being um, the deposit or the the toilet, I guess, for desalination of the brine? How is that going to affect other species? Have you looked into that arena?
Yeah, and it's a question. This is even way before this was a deal. Many years ago, um, we were, well, how could we sample for that? How could we sample for that? I've got like a brand new computer, so I don't know if I can pull up. Oh no, I think I do have some of this in the presentation. Let me pull one of these up. So there's a couple of real logistical issues with sampling for high salinity that would come out of a desal operation. Let me see if she put. I just literally just opened. Okay, there we go. All right, so this is also a study. So for one, these are our buoys, right? So this was our answer for trying to get fixed stations in the bay. So that's the buoy in Baffin Bay. That's there right now. And it was a big deal to put that there. So the problem is you put an instrument out, like, because measuring salinity, you can't measure salinity with the satellite. You have to have an actual sensor. There's only a few ways to do it. One is like there's like the cell, and those are really kind of like cost affordable type of sensors. but those don't seem to do very well with a big variety of salinities, like if it rains or it gets really salty. The ones that we use, it's basically an electrical probe. There's like two little probes, and it just measures the electrical conductivity between the two probes. And every now and then you got to go and clean off the gunk that gets on there, like the algae and whatever. So the problem is you got to put these somewhere. And if you just throw it out in the bay, either it'll get buried in the sediment, or you have to have a mount of some sort, and then a diver. So they say, well, then we need to put it on a platform. You need to put it on something that floats, right? And so there's that method, is so it's a fixed station. The only other thing you have is on the boat. You drive a boat and you put the instrument in and you can get the value. The problem with capturing what's happening from a desal plant is salt water is heavier, right? It's more dense. The saltier water is more dense. It's gonna go to the lower areas. Well, guess what's the lowest area in the bay near you? Is the ship channel.
Yeah.
And guess what drives across the ship channel all day long? Ships. So you can't put a fixed station of any sort anywhere near a channel. There are many famously funny examples of some group putting in this giant, super expensive station that it's even nowhere near it, and the next week some giant barge takes it out. Okay, so you have to put the fixed stations somewhere that's kind of out of the way, out of the realm. And then past that, you've got to have some sort of design. So an example here, this is one of my forays in the coastal group was trying to revisit these things called a estuary survey. They used to do it back in the 80s and 90s, and what they did is they had literally 40 staff, which was like most of the board, and had like 15 boats, like literally 15 boats, and would have someone sitting on the boat, two people on the boat for 12 straight hours, day and night, with shifts, taking measurements. And when a boat would come, they would move and then move back. Okay, so in a couple years ago, I tried to come up with an idea of, well, can we use both fixed stations, instruments we deploy, and then also the boat driving? So those lines that this had, this is a sample. It was a pump that runs on the boat, pulls salt water out for it's basically a washdown pump, like you would use a squirt gun, on the boat. It pulls the water in, runs it through the instrument as you're driving, like on plane. And so you're able to get that surface water, but then of course you don't get the bottom water. So at the same time, you got to stop every now and then and put the instrument down, pick it back up. The key with this, and what I'm getting with you, is that the plan is, and the plan I've kind of proposed, and we try to get staffing for, is can we do this type of data survey in all of the estuaries across the state, is to revisit these ones that we had in the 80s and 90s, because we have those there. So as the morphology changes, as things get put in, then you're able to really tell, does this change in the bay make a difference to salinity, right? Because again, we can't put a fixed station in. That's not gonna show us any change, right? The only way to show change is you have the sample design over a large area, doing both things in different temporal formats and spatial formats in a comprehensive system. And so you run this whole study, and then now whenever a change occurred, or you do it again in a few months or at a different season, then you can see what the change has been. And so that's the plan of what we're looking at. And we're hoping to do Corpus. That is the thing, is to do Corpus, Nueces Bay plus Corpus Christi. We ran Nueces Bay like as a draft to do the tracks, and we ran part of Corpus, the upper part, about a year ago, just to test the tracks out. And so we're at the stage now we could actually do the full thing. But to do it, we basically use every single instrument in our inventory to put them all out, and we do the one bay. So it's like, it's all we can do. So it's a long-winded answer, but that's the plan. That's the idea. And that's saying that would be the only way to measure and understand these, it's like if we like dredging a channel or some big change occurs to the system, you have to have this large spatial coverage to sample that.
Yeah. Just want to kind of update you. I sent Lucy some information a couple weeks ago, but we have a National Science Foundation grant with the University of Texas Arlington. They're doing air monitoring, and they have a water sonde on the pier out here. And so we're measuring pH, conductivity, salinity, turbidity, oxygen, and I think wave height. And so we have a handful of things. Every 2 weeks, we have to have somebody come out here and clean the
Right.
biomatter off. That's
Right.
the problem.
Right.
Although they are trying to install 2 more in Corpus Christi Bay, because this one has been successful. I'll send you a picture of what it looks like, and then also some of the data if I hadn't sent it to you before. But anyway, that may be the next step of going forward and really kind of looking at a study in Corpus Christi Bay that's actually, every 2 weeks isn't too bad to be able to clean it out. So anyway, that's all I have to say. Thank you for your presentation.
Evan, it's Audrey. I kind of have a follow-up question. Are you working, is the surface water working with the groundwater division on the salinity measurements and the impact from the desal? Since the brines will likely end up in the ship channel and the ships going over are gonna create pressure waves pushing it into the sediment, pulling it back out. Any work from the groundwater division there?
I don't think that's particularly a project yet. We do a lot of work with them. One of the big sort of pushes that they've been working on is aquifer storage and recharge is kind of a big one, and especially even in the coast. So that's something that they work on. There's a whole group that does groundwater modeling. There's like a whole analyst group that they work with. So, but I'm not aware of that particular, like, of looking at salinity specifically from a desal. There is a up north, because there are areas of conductivity actually inland, and that's something that is thought about as well. Like there's brackish water. There's actually a brackish group as well, and so they work on particularly those wells up north. So that might be maybe some cross pollination with that group.
This is Doreen Ivan.
Yeah.
Thank you for talking today. A lot of data sources you presented, and with some of them, I was able to capture the temporal maybe resolution, but with others, there wasn't so much information. And for instance, I know I'm familiar with the groundwater database, and a lot of, we're interested in the chemistry. If we want to look at more regional or, certain coastal areas. I was gonna say that it used to be that Texas Water Development Board was doing maybe twice a year sampling certain locations. Of course, they cannot cover all the groundwater wells in the state, because that's crazy how many there are. But I'm not sure what their temporal resolution is now in terms of the chemistry, monitoring the chemistry.
Yeah, I don't know off the top of my head.
Yeah, we found it very difficult to be able to, do a temporal analysis on the chemistry. And for the groundwater elevations, there's some that they continuously monitor, like you showed even there, it's a little confusing when it comes to depths of the wells and, you know, what's the coverage of the aquifer, because you can't just say that that's representative of one location, given how thick the Gulf Coast aquifer is. So just, there are a lot of data available when it comes to temporal. It's a little more difficult to get that and be able to use it in temporal analysis.
Yeah, I mean, I spend a lot of my time working on the websites, and this is one of the things that data collection goes on, but the resources to work on websites have been very low.
Yeah.
So it's not the easiest to pull out. One of the things that I think that we do excel at the board is that customer service relationship. And the person that I would talk to about anything groundwater data is Heather Dodson. So she's kind of my counterpart in the groundwater group. And she would be the one to be able to find either she knows it or find which group that would do that. Because, you know, again, like I'm not 100% of, I don't know exactly what they do. I know that some of the wells have telemetry, but then some do not. And I think that some are modeled and then they just drive around once a year or every half a year just to make sure it shows what the level is according to the model. But she would be the person to ask for that as well, like of what the chemistry is, if they're doing chemistry in any of those ground walls, or even if you're interested in putting chemistry in would be the person to talk to as well. So Heather Dodson is the person to talk to.
All right, thank you. And one last question I have for the freshwater inflow for the modeled ones. Because we have used them in the past, but I remember there was a time delay about 1 year, 2 years. Sanjay, what was it? They were not up to date with those. Do you know how they're doing these days?
Yes, it's generally that. So there's a reason of the way that is. So, and I don't want to be a government person passing the buck, but the freshwater inflow has to, first the year has to finish, right? And the gauge data is easy because USGS has that like up to date daily, hourly, that's done. Then you have to run the rainfall runoff simulation. There's that, but that can be done. The major holdup is getting this diversion and return numbers, because the diversion and return numbers are actually produced by the water right holder themselves. So at the end of the year, and they only report them once a year, and they're like, some of these are actually written paper. So if there's like a plant that say they've got this water right, well, they list down on their own how much water, you know, that they used, and then also the water that they gave back, the return. And then those documents are collected, and then that data is collated and put in a table and then given to us. That is typically the reason why it's so far out. So we've been discussing with the main hydrologist of, can we make an estimate of the total freshwater inflow if we don't know what the diversion and return yet? Because that actually is what holds us up, like why that is a year or two out. And there are certain areas that we feel confident that we can model, like say that if the diversion returns are identical every year all the time and no development has occurred in that area, then maybe we can take a best guess that I'm pretty sure this is probably what it's going to be. The problem is that in that area, it could be very wildly different. So we're kind of uncomfortable of saying, here's a provisional number based, you know, waiting on what the diversion and return is. If that makes sense. That's the number one reason why that's so far out of date.
How How long has it been done? Because I wonder how long before you can actually start predicting.
It, well, the like you meaning like if we don't know what the diversion and return is, how long it would take us to predict it?
Well, no, I'm because you need to have enough historical information
Right.
to be able to predict. So I don't know how far back these models go, if they're able to.
Well, they go back to the 70s. The problem, like,
Okay.
again, there's some kind of famous issues, like, so an example is we looked at one and we're like, oh, surely we can continue doing on this area, because they kept pulling 100 acre feet every month, and it was like a plant. And then we Google imaged the plant and realized that the plant got shut down. And it's just completely shut down. So like we could have been adding that in. So it's like you can't just look at that data of what it did without also kind of taking a look at who are the folks that actually use that water. Did the plant shut down? Did they increase the plant? Does it look like they're still using the same amount of water? There are some that you could totally very easily say that it's the same because it's a power plant that's been there for many years. It's still in operation. They always pull the same amount of water in. You kind of feel confident that you can make that leap of logic. But again, like we literally had to look at the Google and see, does that power plant still exist? Because if it's been 2 or 3 years, and there used to be only 1 year that we were delayed by the diversion return. Now it's turned into a couple years. So it is, in fact, this is what I've been working on. Let's see which, because I'm loading up new data as I'm retooling this entire site. So one of the things like I'm working on, this is part of my job now. There's a backend portal that the staff use to add data, do things to, and I'm creating that whole user interface. And one of them is, you see like how Laguna Madre split up. That staff are actually able to load a different shapefile and change the shapefiles that are there, in the system. So it's not just this page and the data. There's just this whole mountain of stuff in the back end that I have to deal with. So right now, it looks like we get to 2023 is the data that I have, that I'm going to be putting out in the next couple weeks. So like this is like 90-ish% done. And then once I push this out, then it'll be up to, so it'll include your 2022.
This
So
would be
it's pretty
for instance, would be really important for the group that might be looking at the bacteria levels in the Gulf.
Well, in either way, if it's online or not, just let me know if you're looking for particular area or time, and I can get you that data, because I have it on my own.
So if when we see you next week, maybe you have a more concrete like number or something, what's available to let us know when we discuss projects. Thank you. Thank you. Anything from the group? No questions?
Not a question, but a comment. I just wanted to say thank you for sharing some of those like monitoring gauges. Because I do like a time series in the Gulf of Mexico, so I'll definitely be using some of those resources you've shared to kind of look at like some of the seawater parameter data in tandem with what I have. So thank you.
You're welcome. It's hard. From the state, one of the things we have to do is say who's taking salinity records in the state. And that's actually quite hard, because the people that collect data don't like email us and say, hey, by the way, I've got a new station and it's here. So it's a hard task even to find stations. So yeah.
Hi, Evan. For the precipitation data, it's gauge data, or do you also store radar-based data, MRMS or MP?
We don't store radar, so that's going to be gauged precipitation data
All right,
on those mesonet stations. So
got you.
yeah, I would go to NOAA for the radar based.
All right.
But I would love to see some analysis between the gauged data and in the radar. So one of the kind of big things that went out after Harvey was trying to buy very expensive gauges in order to in order to actually record these monster rainfalls. And so not only, but so these stations, not only do they have one, they usually have two, sometimes three gauges on them with multiple different sensor types. And soil moisture was the other one too. They all have soil moisture.
That makes sense for extreme events.
Yeah.
The MRMS should be pretty close because they're using the gauge data when it's available to them for the correlations. But it'd be great to check indeed.
Questions? Okay. Thank you, Evan.
All right. I'll see y'all on the 14th. Thank y'all.
See you next week.